Welcome all. So this is me, Satish, Assistant Professor from Department of EEE. So I'm going to handle a session on principles of robotics. So we have an outline for the session. So the principles of robotics, as we start, we'll have an outline. We will have introduction first. We'll also discuss about history. Followed by that, we'll see the classification. After classification, we will see about the science behind industrial robots. After which we'll go on understanding about the future scope and conclusion. So the word robot, as we speak, was first introduced by Karel Čapek in the year 1920 in his writing segment, where it was coined as robota. So after which, as many years goes on, and every 10 years we find a reformation in the definition of robot. So what does this word mean? What does this robota means is that it is a forced labor. So which is, for your understanding, we are going to make a machine work for the humans. So that was the first abstract idea about what is meant by robot at the very beginning in the years 1920. As years pass by, the definition for robots gets transformed, and again it was streamlined by different companies. And if you ask me now what is the definition for robot, we have certainly 100 or 120 definitions. So we will see about that. So this is all about the history where the word is being coined and how it is being traveled and how what is it is currently present now. So the understanding about robots requires automation first. So the automation is alone enough, if you ask me. It is not like that. We also require some intelligence which is able to take the course of actions, decide and decide on its program how it is being done, and it is able to do the tasks without any human intervention. So this is all about the basic definition. With respect to companies, we can even define in a more scientific way, but since this is an introduction part, this is more than enough, I think. So followed by this is our outline for the session. We will have introduction, classification, followed by the science behind industrial robots, and then the future scope. What is the next future when we pursue robotics? So this is all about the session for today. So we start with the classification first. So the classification can be, in a general perspective, divided into two. One as intelligent robots or robots, and the other as industrial robots. Two I's for easy to remember: intelligent and industrial robots. Intelligent, as we say, it corresponds more about the cognitive intelligence which is gained by the neural schema, algorithms, etc. We talk more about the learning factors, learning perspective of the artificial machine. Whereas in industrial robots, it is not like that. It is all upon the application area. So it is with respect to the type of configuration we choose for a particular application, the classification is divided. So our focus in engineering perspective, we handle both intelligent as well as industrial robots, but this session's focus will be upon industrial robots. So, hope I made my point clear. So, in industrial robots, again a subclassification is going to be made. So, this subclassification will be based upon the ARM configuration. So, what is ARM? Why it is classified based on ARM configuration, that we will see. So, when a basic industrial robot, if we take, the different parts starts from the base, followed by the base you will have lower arm, and followed by that you will find upper arm, and finally your wrist configuration, and the wrist configuration holds end effector. So, the application, the perspective all changes when we choose a particular end effector. So, there can be many types of end effectors. A company can make the arm configuration to be fixed, whereas the end effector is upon the choice of the customer. So, the customer can be an industry, can be a normal consumer, it all depends where I am going to employ this robot. Okay. So, we will talk about the parts of the industrial robot. So, the industrial robot has the following parts. First, it has a base. Second, it has an arm. And arm has two things to be noted. One is link, another is joint. And followed by arm, you will have the wrist configuration, and after the wrist, you will have end effectors. So, end effectors are the key which are customizable with respect to the application. So, these are the body parts. We start from the base, arm, wrist, end effector. In arm, you will find link and joint. So, what is this link and joint? So, a non-movable body part, the physiological structure, we term it as link, and this is an example for that. Say this is a link which has a non-movable body. A joint is one which serves the purpose, which creates the movement, and it can be classified into linear and rotary. So, what is linear joint? It is otherwise known as prismatic. Notified as capital P. This can be called as revolute joint also. It is notified as R. So, when we combine a non-movable body part to a joint, this non-movable body part becomes a kinematic chain. That is, the non-movable body part is able to move now with the help of the joint. This is how we create a kinematic chain. So, kinematic chain is not simply about one link connected to a joint, rather you will have multiple number of links and joints connected together. So, the whole assembly we call it as kinematic chain. So, this is all about the ARM configuration, and we have certainly different classifications based on the type of joints we employ, that we will see next. So, followed by that you will find the wrist. So, the industrial robots idea is it is going to mimic the whole body structure of the arm, human arm, which has three primary joints and many number of secondary joints. The primary joints are, we start from the shoulder, followed by the knee joint and as well as the wrist. So, that is how it is also a base, an arm and a wrist. So, you can compare things with your human arm, where the parts have been listed, and followed by the final end effector, which is your finger assembly, which has many number of secondary joints to be present. So, the next phase of the presentation class will be about the classification based on the joints in arm. So, we are taking the concept of arm. We do not speak much about the base, because base gives me a platform where the robot can be held. The whole structure, weight of the robot alongside of the load, the bearing capacity, all depends on the base region. Okay, so this is where we stop, and we will continue further with respect to the ARM configuration.